Hey everybody, welcome to another Intro to Java Programming video. In this video I'm going to wrap up everything we've talked about in the previous few videos. I'm going to talk a little bit more about methods and parameters. I'm going to talk about setting things relative to one another. I'm going to talk about the use of variables and things like that, and I'm just going to kind of wrap up everything that we've talked about so far and cover all of the skills that you're going to need for, well, I shouldn't say all. Most of the skills that you're going to need to put together your Smiley Face project. Right, let's get started. I'm going to run this program. You should have your ovals class open. And what it's going to do is it's going to draw some concentric ovals, two sets of concentric ovals. So there's one larger set here and another one right here. And they're going to draw in random locations, of random size, and of random color. Let's look at how it's done. In the main method, it's going to do everything we always do in the main method, instantiate an object of our class inside its main, set the size, set the default close operation, and set visible. I also have one more thing in here called Initialized Variables. This is new. This isn't something from Java. This is something that I created. What the Initialized Variables method is for is resetting the values in these three instance variables, x, y, and h. Okay, this might even better be called, instead of initialize variables, maybe call it reset variables. And I'm going to show you something called refactoring. If I highlight an identifier like this, or a name of something, I can right click and choose refactor. It's about a third of the way down on that menu, and then go up to rename. When I click on rename, it's going to highlight this field, and I can change it. I'm going to call it reset variables, and then hit enter on the keyboard, and it'll change it everywhere else in the program. See, it renamed the method here, and anywhere I call on reset variables, it's going to rename that as well. That's called refactoring. All right, so now that method is called reset variables instead of initialize variables. Probably a better name. Now let's take a look at what that does. Now the nature of a method call, as you know, is that when a method is invoked or called, the invocation always looks like this. You've got either some object or class name, object if it's instance method, and class name if it's a static method. You've got the dot operator. The dot operator is kind of like opening the door to some sort of member, either accessing a variable like we've seen before, or accessing a method. And then we've got our method call. And the method call is going to transfer control of the program to that method definition. So when we encounter this frame.setVariables, it's going to transfer the control of the program to reset variables. In other words, it's going to search in the class that the object frame is. So it's going to look in the ovals class, and it's going to look for a method called reset variables that has this exact same signature. In other words, it's going to be called reset variables, and it has no arguments in the parameter. So we'll search for reset variables. And here it is. And control gets transferred to this point right here. All right? And now it has to execute everything inside of that method. This is the nature of a method call. Now, to review why we make methods because these are going to be things that we are going to do over and over and over and over again. We do this for the concept called software reuse. In other words, if there's something that needs to be repeated, probably throw it in a method and just call on the method instead of having to rewrite that code every time. I don't want to have to rewrite this code every time I want to reset my variables. I just want to make a call on this, much shorter and much sweeter. All right, so a method invocation happens, transfer of control moves me to right here, and what I'm doing is I'm resetting the values of x, y, and h, and I'm using that the skills that we learned previously in the randoms video. If you haven't watched that, you need to go back and watch it, because I'm not going to explain what these do. They're just generating a int between 1 and 300, 1 and 300, so x and y can show up in between 1 and 300, and another int in height between 150 and 300. And I want it to be between 150 and 300 because I don't want the ovals to be a size 0 or 1, and I don't want them to be so enormous that they're going to be too big for the frame. Okay? All right, so that's my reset variables method. It's just going to set those values, and I can use that as many times as I want. Once that method terminates, control is transferred right back to this point where we left off with the method call. So once again, method call happens, dot operator in a method, control transfers to that method, it executes everything inside of it, we get to the end, the method terminates, and we transfer control right back to where that method was called. There we go. Now we're going to finish out the main by setting visible true. It's going to make that frame pop up on the screen, our ovals are going to draw, and we'll be happy. Now, when set visible true happens, as you know, it's going to invoke the paint method. It's going to do it implicitly. We don't call on paint or repaint here. It's just going to do it. So let's look at the paint method. Paint method, as always, calls on super. And then we're going to make a call to a method called random ovals. So as you know, when we encounter a method, it transfers control of the program to that method. So it's going to search for a method that has a signature called random ovals that takes in 3 ints, a graphics object, and a color. Okay, so we're going to search for that inside this class. Random ovals is right here. So it would transfer control to this point and execute all these. But wait a second, we can't jump up here yet, and I want to talk about why. There's something different going on here. In this method call or method invocation, I have another method invocation inside of the parameter. All right, let's talk about the nature of these parameters, and then I'm going to talk about this make random color method. Review. Parameters are sets of variables that are accessible only inside the body of a method. So when I make this method call, I pass some values into what's called the actual parameter. This is the actual parameter. It's the set of fields that I pass things into in the method call. When I pass things into those fields, they get assigned into variables in the formal parameter. The formal parameter is this set of variables that is declared inside the method definition. Okay, so let's talk a little bit about this again. I know I've talked about it before, but I just want to make sure we really hit this because I think it could be a confusing concept. So the method definition is going to have this set of variables that we declare inside of it. It's called the formal parameter. And when a method is called, so the method is called right here, the first thing that Java is going to do is in memory set aside space for each of these variables. It's going to set aside a space for an int called x, an int called y, an int called size, a graphics object called g, and a color object called color. That's the first thing that's going to happen when the method is invoked. All right, so these variables pop into existence, and then they're going to take these values into them. So they're going to take in this case, the value that's held in x, the value that's held in y, the value that's held in h. It's going to take in g, this graphics object here, and then it's going to take in what comes out of this, make random colors. Now, once those things are assigned into those variables, we can use them inside of the method. So inside of the method, I'm going to use the value that's held in x, the value that's held in y, the value that's held in size, the value that's held in g, and the value that's held in color to set the color and draw my ovals. Okay, that's how method parameters work. The actual parameter takes either variables or literals or method calls into it. It assigns it into these formal variables here, and then those values get to be used inside of the method. The reason we do this, as I stated in a previous video, is for abstraction. We want to be able to write functions that we know what they're going to do, but we don't know exactly how they're going to do it. You know, we know that this is going to draw ovals, but we don't know how. We don't know where they're going to be drawn, we don't know what size, and we don't know what color. So we set these things up with the abstraction of variables, and then when somebody calls on the random ovals method, they can decide what's going to go into it. It allows us for much more flexibility and dynamic programming. All right, so that's a little bit more about method parameters and how they work. Now, let's go back up to that method call, because as I said, it had something weird in it. Let's talk about how this is going to execute. When random ovals is called, it's going to take the value that's in x and assign it into the formal parameter x, take the value that's y, and assign it into the formal parameter y. Take the value that's in h and assign it into the formal parameter size. Take the value that's g and assign it into the formal parameter called g. And then wait a second, we've got this. This is a method call. Before we can actually get into the body of the method, this method here has to resolve. Because, as you know, when we encounter a method call, control of the program gets transferred to that method. So I've got this method called makeRandomColor. And now Java's going to search for that. And it's going to find it right here, makeRandomColor. MakeRandomColor is a return method. We've worked with return methods before, but we haven't really talked about them. We haven't created them yet. A return method example that we've seen before is math.random. We know that when we call on math.random, it gives us a double between 0 and 1 exclusive. That's an example of a return method. Well, when we define a return method, it's going to look like this. You've got your access modifier, you've got your return type, and you've got your identifier and parameter list. MakeRandomColor doesn't take anything into the parameter because it doesn't need anything. All it does is generates 3 ints, and then it returns a color. Now, the return type. The return type can be any Java type. It could be primitive types like int, double, short, long, Boolean, whatever. Or it could be reference type, like color or string or any other type of object that we could think of returning. In this case, I'm returning a color. So what I want to do with this method is generate 3 random ints between 0 and 255, generate a new color, and return that color. Okay, so that's what's happening. So we're taking that R, G, and B, and we're passing them into the constructor of our, or passing them into the parameter of our color constructor and generating a new color and returning it. Now there are a couple ways of doing this. We can either instantiate our colored object directly in the return statement, or we could go about doing it in a little bit more decomposed fashion. We could make a variable. Color C gets new color RGB, and then we can return C. Okay? Or we could just directly pass this construction of a color object into the return statement. Either way you do it is just fine. I usually like to do it this way because it is shorter and sweeter and requires no variables. To make this even shorter and sweeter, I could get rid of these 3 variables and take the just the random generator and pass it into these 3 parameters, just like this. And this is going to be a little less readable, but it uses fewer variables, and it's all on one line. Any way you want to do it, either more decomposed or more composed like this, is totally fine. I don't care which way you do it. Do it whatever way makes sense to you, and just make sure your code is readable. I believe that this is still readable because I know that I'm generating a new color. I know what math.random does, and so these 3 calls are the same. I know this is generating a random color. If I feel it's at all confusing, I can always throw a comment in here. So generating 3 random ints, 0 to 255, and using them to make a color. So that's how you could handle this if you want. Do it whichever way you want. If you feel it needs to be broken up and decomposed more so that it's more readable and clearer, that's totally fine. All right, so that's my random color method. And what's going to happen is when I call on makeRandomColor, it's going to execute all those statements, and then it terminates. And when it terminates, it's going to return or give us a color. So as I said, it's got a return type, it's got a return statement. That return statement is going to spit out whatever value is right here, and it's going to spit out that new random color. And it's going to spit it out right where that method terminated. So if I called that method right here, it's going to give us that color right at this point. So that method gets called, we execute everything in the body, it gives us a color, and that color is now going to get passed into random ovals. All right, I feel like we went down kind of a major rabbit hole there, so let's kind of review. In the main, we start by resetting variables. Next, we go to paint, call on the super, and then we call on random ovals, which is going to take an X, a Y, an H, a graphics, and then make random colors. So it's going to create a random color and return it to this point. Now, let's take a look at the definition for random ovals, because this is where everything is really happening. Random ovals, in its formal parameter, as you know, takes in an int called x, an int called y, an int called size, a graphics object called g, and a color called color. And we're going to use these to set the color of the graphics context and then draw two different ovals. All right? Now, let's take a look at how this is done. First of all, we're going to set color, and then I'm just going to have a print statement here that's going to print out the x, the y, and the size so that we can see that down in the console here. All right, then we're going to draw an oval using x, y, size, and size. We're using size and size in the same value for both height and width, so that it always generates a circle instead of an oblong oval. Then we're going to draw another oval here. And what we're going to do here is we're going to make some calculations. When I make these calculations, let's take a look at what's happening here. I'm taking my x, and then I'm adding something onto it, okay? I'm adding size plus 10%. And let's talk about what that actually does. So my x here is going to determine how far over to the right my oval is going to be, okay? So the first oval was drawn at x and y, and it's size by size. My next one is going to shift it over to the right. I know it's shifting it to the right because I'm adding. Think about the grid for a second inside of a graphics context. As the numbers get bigger for x, it goes to the right. As the numbers get bigger for y, it goes down. So if I add something to x, that means it's shifting over to the right. So what I'm doing here is I'm multiplying my size by 10% or by 0.1. So if my size was 227, it's going to multiply that by 0.1 and give us 22.7. So if my x was 100, x would be 100 plus 22.7. So it would be 122.7 is what my x would be. So if my x here was 100, this one would be at 122.7, thereby shifting it over by 10%. Okay, so you can see this smaller oval is shifted over to the right by 10%. We have to then cast this to an int. The reason we have to cast it to an int is because draw oval expects 4 ints. And when we do this calculation here, as we learned in a previous unit, size times 0.1 is going to automatically convert that int into a double. And then add it to x, it's going to convert it to a double. If I don't have this int here, you're going to see that it's going to say an error. It's going to say wrong first argument type. Found double, required int. So in order to deal with that, we'll cast it to an int to make sure that you can pass it into the parameter. Another way of going about this without having to cast to an int is we could just do size divided by 10 plus that. It's the same thing. It's an equivalent statement doing something different, and then we're not dealing with those decimal points and casting. So either way you want to do it is totally fine. So I'm going to do that with the y as well to shift it down by 10%. And then what I'm going to do is I'm going to shift it to the left and up. Okay, so I'm going to make it bigger and bigger. It's going to get bigger in the width and bigger in the height by 20%. And let's see why that is. If I'm shifting it, or pardon me, it's not getting bigger, it's getting smaller. Anyways, so my larger oval here was drawn, and then I shift the smaller oval down by 10% and right by 10%. Now I have to make that oval 20% smaller because I want to have a 10% buffer all the way around it. Okay, if I want a 10% buffer all the way around it, I need to make sure it's shifted to the right and shifted down. Okay? So what I'm doing here is I'm multiplying size by 0.2, which is going to be 20% the size, and I'm subtracting that from my size. So I'm subtracting 20%. So this means it's going to be 80% the size of size. So I'm doing that for both the width and the height. So here you have it. I've got my original oval drawn at X, Y, size, and size, and then I've got it shifted to the left by 10%, or pardon me, to the right by 10%, shifted down by 10%, and then shrunk down by 20% and 20%. That's what random ovals does. Now, why are we doing this? Well, here's the deal. You need to make a smiley face, and a smiley face has two eyes and it has a mouth. What I'm going to do is I'm going to just try and see if I can change this into a turn this into an actual smiley face. I want the eyes to be about 10% the size of the head. Okay, so if that's going to be the case, I need to change how big it is for width and height. I'm going to change it by doing this. I'm going to take this off of here, and I'm just going to divide the size by 10. If I divide the size by 10, this one is going to be 10% the size of this one. I'm going to do that for both. I'm just going to change this and check it. I'll run it, see what's different. Okay, see, this is now 10% the size of the original head. Maybe that's a good size, maybe it's not. You'll have to decide. Personally, if I were going to do this, I would want the eyes to be a little bigger. Maybe see what it looks like if they're 20% the size. And that's way too small. We don't want to divide it by 20. Let's divide it by, so if that's 10, let's divide it by 5. Because that's 20% the size. And that's a little bit bigger. Maybe that's better. I kind of like that. I kind of like the larger eyes in the smiley face. But they're not in the right location. Because our origin, once again, is still 10% shifted down and to the right. I have to shift it down further. So let's see what happens when I increase this value a little bit. Instead of divide it by 0.10, let's see what happens when I divide it by divide the size by 4. Okay, that moved it down and then over. What this is doing is it's taking a quarter of the width of my smiley face and it is adding it onto the X and Y value. Okay, I think that's a pretty good placement for an eye. You think? I don't know. It's up to you. You have to decide because you're going to draw the smiley face. This is where I'm going to leave it. From here, you're going to have to figure out how you're going to draw this eye right here, how you're going to draw the smile right here, and how you're going to make it so they always appear inside of the smiley face. We never want them to appear outside. Okay? You can see every time it regenerates, those eyes are always proportional to where they were originally. Kind of looks like the Death Star. Now, lastly, you have to think about how big those smileys are going to be and where they're going to be placed. And as I said before, this is not necessarily the best way to do it. In fact, for the project, this is not acceptable. This is always going to put the X and Y between 1 and 300. Well, we got a problem here. Because potentially, these smileys could generate off the frame. See that? They're generating off the frame because I resized it to be smaller than 300 by 300. And if we make the frame really big, they're always going to generate only in this area. They'll never generate and use any of the rest of this space. That's a problem. You want to make this more flexible. In a previous video, we talked about using get width and get height in order to see how big the J-frame was. Okay? We also talked about generating an oval that was going to be the appropriate size for the frame. We have to figure out the maximum X value and the maximum Y value for the frame. And we have to think about how big the smiley face is. I'm not going to expand upon this anymore. I've talked about it in a previous video, and you have some PDFs available to you to peruse, and it'll help you answer those questions about the Smiley Face project. So here you have it. This is all you need in order to do the Smileys project. I hope this was helpful, and good luck doing your project. Thanks for watching.